All right, this is part 2 of differentiation rules. So we're really going to be talking about the product and the quotient, and then second order or higher. Later on, we're going to talk about the chain rule. So what happens if I have a function inside of a function? Okay, so the product rule is if I have the product of two items here, what I'm going to do is I'm going to take the first function times the derivative of the second function, plus the second function times the derivative of the first. So u times v prime plus v times u prime, okay? Here's example 1. I have 1 over x times the quantity x squared plus e to the x. Now, yes, I could distribute 1 over x into this and kind of simplify. That's fine. That kind of defeats the purpose. I want you to understand that this here is actually equal to x to the minus 1. Okay, so we're going to convert that. So what I can do is I can take my first function here and I would go, okay, so y prime is equal to 1 over x. And I'm going to write that as a power. So x to the minus first times the derivative here. Well, now I have a power rule. So x squared, so I'm going to bring my power down. 2x, 2 minus 1 is 1, so I have 2x, plus the derivative of e to the x is e to the x, plus, now I have my second function here. So I have x squared plus e to the x times the derivative of x to the minus first. Well, this is power rule, right? I'm going to bring my negative 1 down. So negative 1 times x, negative 1 minus 1 is negative squared, okay? I can distribute this. I could simplify this. So I have, so this is going to give me 2 here plus e to the x over x plus, well, so I have x squared times x to the minus, which is minus 1. Now I have here I have minus e to the x over x squared, and the 1's going to cancel out, so I have 1 plus e to the x over x minus e to the x over x squared. Okay. Now this next one is a little bit different here, and it's e to the 2x. Well, e to the 2x is really e to the x times e to the x, right? So now if I want to go y prime, I have e to the x times e to the x. So I have e to the x. The derivative of e to the x is e to the x plus e to the x times e to the x, which is going to give me 2 e to the x of 2x. That one's kind of like a little bit of a brain teaser. Now this next one is a lot more of what we see. We usually see two functions like this. We could multiply them out, create a polynomial, but it's faster to go ahead and take the derivatives of each individual one. So I'm going to take my first one, x squared plus 1 times the derivative of the second part. So the derivative of x cubed is 3x squared. The derivative of 3 is 0, so there's my product there, plus, now I take my second one, I multiply it times the derivative of the first. Well, the derivative of x squared is 2x, derivative of 1 is 0. Now, I could simplify this. There might be some times where we're trying to save time, we wouldn't simplify this. 3x squared times x squared is 3x to the 4th, plus 3x squared, plus 2x times x squared is 2x to the 4th, plus 6x. So let's see, we have 5x to the 4th plus 3x squared plus 6x. Okay? The quotient rule. Okay? So if I have the fraction or the rational expression, so d dx of u over v is going to be v, derivative of u, plus u, derivative of v over v squared. Or vu prime minus u v prime over v squared. Now, this is all fine and dandy. The way that I remember it is I remember there's a high and a low. I know that d stands for the derivative, okay? So the way I personally remember it is low d high minus high d low over low low, okay, or low squared, right? So that tells me I'm going to take my low function times the derivative of my high function minus my high function derivative of low function over low low, which is low squared, okay? You could just memorize the formula. That's just something I do because it helped me remember it, okay? So now I'm here at y prime. So the low function or the bottom function is x cubed, so x cubed plus 1. Now I'm going to d, or the derivative of my high function. Well, the derivative of x squared minus 1, the derivative of x squared, pull my power down, 2x minus, the derivative of minus 1 is 0. So now I'm going to take my high, x squared minus 1, times the derivative of my low. The derivative of x cubed is 3x squared. The derivative of 1 is 0, so I have 3x squared there. Now I have x cubed plus 1 quantity squared, okay? I can do some simplifying here. 2x times x cubed is 2x to the 4th minus 2x minus, I'm going to just put this in parentheses, 3x squared here becomes 3x to the 4th minus 3x squared over x cubed plus 1 quantity squared. Distribute my negative here, so I have 2x to the 4th minus 3x to the 4th minus x to the 4th. Negative negative plus 3x squared minus 2x all over x cubed plus 1 quantity squared. Okay, so there's my derivative. I'm going to leave it like that. I could square that out. That's something you can do on your own if you want. Second or higher order derivatives. So the second derivative is the derivative of the derivative. So you're going to take the derivative twice. Okay? Third derivative, fourth derivative. That just tells you how many times you're going to take the derivative. Okay? So f double prime is the second derivative. And we're going to talk about this. This is where it gets really, you start seeing calculus in a variety of different sciences, like physics and finding the velocity and acceleration and using these different derivatives. Okay, so the second f double prime is e is equal to y double prime is equal to d squared y over dx squared. So it's just the second derivative. So you're taking the derivative of the derivative. Okay. So it says find the second and third derivative. Well, the first thing I have to do is I have to find the first derivative. So I'm going to do f prime. Okay, so what I'm going to do here is now this is just the sum or difference of a bunch of different functions, and a lot of them have a constant multiplier. So what I'm going to do is I'm going to take the derivative of this. So I'm going to start here on the left, and I'm going to take the derivative of x to the 5th. Well, that's a power. So I'm going to bring the 5 down, subtract 1. So this becomes 5x to the 4th minus. Okay, now I have a constant multiplier, but I'm going to really take the derivative of x to the 4th, which tells me I'm going to bring my 4 down. So negative 2 times 4 is negative 8x cubed minus, I'm going to bring my power down and multiply it, 9x squared plus 8x plus 6. I don't care about the 37, it goes away, right? Derivative of a constant is it. So there's my first derivative. Now I have to take my second derivative. So I'm going to take the derivative of my derivative. Okay, so now I'm going to take the derivative of this. So 5x to the 4th, I'm going to bring my 4 down. 5 times 4 is 20. 20x cubed minus 24x squared, so 3 times 8 is 24, subtract 1 from the power, minus 2 times 9 is 18x, plus 8, 6 goes away. So there's my second derivative. Now my third derivative, I'm going to do the derivative again. So this gives me 60x squared minus 48x minus 18. And I could continue to take the derivatives and take the derivatives and take the derivatives of this. There are some functions that don't have a limit on how many derivatives you can take of it, like sine and cosine. So that's the second part of differentiation rules, talking about product, talking about quotient, talking about how to find the second, third, fourth, fifth, sixth derivative of a function. Okay, so just remember that higher order derivative.